Hi everyone, welcome to my talk, bringing legacy code bases to Android. It's been a while since I've been in front of a physical audience, at least that's physically present here. So be gentle, it feels like my first time again. Let's get started. First, maybe an introduction to myself. I'm Michael Demey. I'm the research manager at iText Software. What that means to a day-to-day basis is that I'm in charge of a team. I lead a team of software engineers that is responsible for innovation and standardization. So basically, we write prototypes all day and we talk about PDF during lunch. My second daytime job is being a dad of 2 young children. They are the brightest children I've seen, of course, and I hope they are smarter than their dad and don't choose a career in PDF. Next to that, I'm a double bass player. I love playing double bass. If you're also a musician, feel free to grab me after the talk and we'll talk about music. PDF is an open standard. It's not property of Adobe anymore. There's a common misconception, and as such, it's been donated to the ISO. The ISO is the International Organization of Standardization, meaning that projects at ISO are being maintained by a group of volunteers. And I'm one of the 5 experts for the Belgian delegation in that regard. I'm also very active on Twitter to do some developer marketing, and those are our handles up there. So you have my handle and the iText handle. If you want to follow the corporate news on iText, follow the Twitter of iText. If you want to follow PDF memes, feel free to follow me. So I post stuff like this during office hours. It's great. But I also take PDFs in the wild and I analyze them just to see what's wrong with them, and I go through step by step. So if you're interested in the deep, hard technical stuff of PDF, feel free to follow me. So this is an example of what I try to do on Twitter. It's from a PDF file that was going wrong, that threw some errors in Apache PDF Box, for instance. So as the last for my introduction, I have to tell you a bit about iText Software to make my marketing department happy. So iText is a leader in PDF technology. It's an open source library written in Java and then translated to C#. And we have about 125 plus million users worldwide. We are at the forefront of PDF technology. As I mentioned, I'm a member of the ISO. We're also a member of the PDF Association, which is an industry collective of vendors, of PDF vendors, trying to further the goals of PDF, try to bring it beyond what it is today. And as mentioned, iText, the software, not the company, is multi-platform. It's Java.net, and as of recently, Android. Then we have about 7+ customers across all industries. This is a non-exhaustive list. I'm not going to show you 40 slides of customers. But if you are a customer of ours or a user of ours, you're in good company because of the good people up on the slide deck here, but also because of our support engineers who are very awesome, I would say. So with the introduction out of the way, let's start with the objective of today. So we'll talk you through how we brought iText, which is a relatively old code base, to Android. It wasn't without any hiccups. It wasn't without any efforts that we had to do. So I just wanted to highlight a few of those efforts, not all of them, but just show you what we did and what went wrong and what went right. So maybe first, let's define what a legacy code base is. Like if you would Google it, if you would search for a definition, you would find this on Wikipedia. So it's a legacy code is old computer source code written over many years, and it's obsolete, or at least in some respect obsolete. In most senses, it's like having an old product, an old software service somewhere that some customer is still paying for even after all those years. But for today, I want to slightly modify that definition, and I want to go with this definition, or at least some version of it. So it's a code base that is being repurposed, refurbished. It's not specifically designed nor developed for a new target or a new market. In our case, we designed iText initially for Java 5. I know that hurts to hear, but that's just how it was designed initially, and then we moved it up. But it wasn't designed for Android, and there's many differences between Java and initially what Java was for Android. So that's what we will use for the definition today. So imagine it's late 2021. You just had your first COVID booster or your second one, I don't remember. You're still feeling a bit woozy. And then an unnamed product manager from somewhere comes to your desk. And he asks you, what is needed to bring iText 7 to Android? And you tell him, well, Andre, we've done this in the past. We did this for iText 5. We know a few of the steps. We haven't done it for iText 7. And of course, you've done this before. Andre knew this, but I'm just gauging your reaction. Yeah, we've done this before. Actually, we did this quite a while ago. I'm not sure if it projects pretty decently on the screen. It does, actually. So we did this way back in 2012, 2013. So for iText 5, we have a few versions up on the Maven Central repo. I think even the latest one, 5.5.12, 13 is on there, but the screenshot doesn't show me. Let me just put the laser pointer up as well. So we've done this in the past, and there's a few steps that we had to take back then that are very different what we had to do this year to bring iText 7 to the Android platform. So for those of you who don't know, so just a slight introduction to iText 5. iText 5 is different from iText 2, which you most likely will know. And iText 5 is the first AGPL-based iText version. The original license for iText was MPL LGPL, and we licensed iText basically to be able to build a sustainable business model around it, in the sense that we now are able to sell commercial licenses for people who don't want to adhere to the AGPL rules. For instance, one of the more common objections towards the AGPL that some certain verticals have is that you have to open source your source code to your users, or you have to provide your source code to your users. And you can imagine that some industries are not very keen on doing that. So we offer them a commercial license. And that's how we were able to build a sustainable business model. I mean, it's been 11 years and we're still here. We're still talking to you guys. So that worked out pretty great for us. iText 5 is the immediate successor to iText 2. 0.1.7 was the last version, I believe, but with a slight asterisk. So you could take your source code, your code that works with iText, and you could just use it for iText 5 with the notion that you would have to change your namespaces. The old ones were assigned to, the old namespace was Bruno's name, basically, and we changed that to the company's name. So that's a small caveat there. Currently, iText 5 has been superseded by iText 7, but the intent is still very much the same. So for iText 5, when I made the effort to get it on Android, we had a work name for it. We called it iText Google, because at the time, well, it still is actually, there were very different provisions that you had to do to get on Android. The JVM isn't the JVM that is, or at least the API that is running on Android. And Google App Engine was also a very prominent thing back then. And there were some things that you had to do differently for Google App Engine and Android. But most provisions, they overlap or they complement each other very nicely. So we chose to combine the version that we would launch for iText Google, and then we would just have one version, one extra jar file to build. And the iText Google name just stuck around, and we just named it iText G because it's an OG. So yeah, that's iText G's history a bit. So what is special about iText G? For those of you who were around about a decade ago working with Google App Engine, you might remember that they had a list of banned APIs. There was certain stuff that you couldn't use from Java. And the thing that came to mind, comes to mind right now, is that the graphical things, you cannot use them, like the graphics 2D stuff or AWT classes that you can't use. I forgot to introduce Google App Engine. So it's a cloud computing platform. Feel free to Google it. It's been around for a long while, but it had its own version, or at least its own slimmed down version of the API, of the Java API. For us, the main thing was that the graphical classes were affected. We try to be a bit more. We try to be platform agnostic, but we also try to offer shortcuts. Like AWT has a lot of interesting or useful classes for people, and unfortunately, AWT was on the list. So we had a dependency on AWT. First of all, to load in buffered images, so you could just load up your Java object into iText, which would then transform it into a PDF image. Needed to convert it maybe, depending on the type of image that you provided to it. And more importantly, or at least with a bigger impact, is that PDF graphics 2D was not allowed. Graphics 2D is the interface from Java, which allows you to draw path operations to a screen, like a bit like a canvas, basically. So you draw a rectangle, or you draw a curve, you draw text at a certain position, and stuff like that. We implemented that because that translates very well to PDF syntax. But that was not available on Android, was not available on Google App Engine. So, sad face for that. Another very important aspect of it is that we, PDF, as you might know, has options for cryptography and encryption and digital signatures. You can encrypt a PDF file, you can sign a PDF file. And to do that, we didn't try to reinvent the wheel. I mean, with iText, we tried to avoid having you reinvent the wheel by writing a PDF library. The same we do with Bouncy Castle. Bouncy Castle is a very mature crypto library. It's available on many platforms, and Java is one of them, as is C#, so we use them on both platforms, actually. So we use them for encryption and decryption, obviously, and also for signatures, for hashing and signing the hashes. The big problem with Bouncy Castle is that initially it shipped with Android. So Android shipped with Bouncy Castle, with a version of Bouncy Castle. And the thing about Bouncy Castle is that it works with reflection. So whenever you try to load an algorithm, for instance, or at least back in the day it did, when you try to load an algorithm, it will try to find the class at runtime and then load it dynamically. And multiple versions on the class path would have a namespace conflict, or at least an uncertainty to which class would be loaded first. And that wouldn't be an issue in normal cases, because if you go to major versions and minor versions, then you could at least gauge the impact of it. But Bouncy Castle, at least back then, had the, I wouldn't call it a habit, but it happened more than we liked, that they would break between APIs between certain versions. So I remember like going from 1.42 to 1.45 or something like that on Bouncy Castle. It would break certain things, so we had to be careful upgrading Bouncy Castle dependency versions. So you can imagine if your Android ships with Bouncy Castle and a customer ships with iText with Bouncy Castle as well, then there's an uncertainty to which version would be loaded dynamically on the class path. And that would lead to unexpected behavior in crypto functionality. It would lead to buggy behavior. We got some bug reports actually on that. And if there's one thing that you don't want with crypto behavior, it's that it's unexpected. So don't rely on like an insecurity or an uncertainty in that aspect of your application. So how did we solve this? We solved this in a straightforward way, because we didn't do that much. The guys at Bouncy Castle, or the guys and girls at Bouncy Castle, they figured out that they also had customers that ran into the same issues. So they released SpongyCastle. SpongyCastle is basically the same thing, just in a different namespace and a different name attached to it. So they realized, don't rely on the critical dependency that shipped with an OS. Especially because crypto is quite critical in most cases. Like, you don't want your signatures to be like unexpectedly behaving or stuff like that. You don't want your signatures to go bad or validated badly in a wrong way. Additionally, Android can be a bit finicky across versions and vendors. So unexpected behavior, as mentioned, we did get some bugs from customers back then. So it's Bouncy Castle in different namespace. That's awesome, right? So those were the two big things that we came across for iText 5. And I'll explain to you later on how we got to that point, how we implemented that specifically, the changes there. And then iText 7, how is iText 7 different from iText 5? So it's still AGPL, don't change your winning theme. We still have the commercial license AGPL combination running. But for iText 7, we have a disconnect in codebase and in compatibilities. So by that I mean that we broke the API for it, so you cannot port your iText 5 code to iText 7 by just copy pasting. You need to make changes in your code base. And there's a few technical reasons for that, because we ran into some walls, we ran into some limitations in our implementation that we've written in our PDF implementation. But there's also a new approach to features and functionality back then. So now we also offer plugins on top of iText that are closed source, which allow we couldn't really properly do that with iText 5. iText 7 allows us to be more modular and to allow for that, which feels like a good use case to us, a better sustainable business model. So just to highlight very briefly why we had to change from 5 to 7. So in PDFs, you can have text in PDF, right? So and to render text, if you want to be intelligent about it, you're going to use font files. And font files, our implementation initially was quite limited, quite Western world focused. Like most of us use a Latin-based script, right? Like you have Dutch, French, Norwegian. So you always have like the same similar characters with some difference in it. My name, for instance, has like the umlaut on the E and stuff like that. But basically, it's always very similar to each other, both looks-wise, character-wise, glyph-wise, but also like behavioral-wise. A character is a character. If you look more to the east, like to Asia, Eastern Asia, there's this whole ecosystem of complex scripts, of complex alphabets that it's really difficult to get your head around if you're a Westerner. For instance, I've got an example of Devanagari on the screen, and the one on the left is the correct one, and the one on the right is the incorrect one, I believe. So for us, the difficulties would be that for instance, this floating C and this floating sideways I, they should interact with the characters in a correct way, instead of just showing them where they should be placed according to the font tables and to the characters that are being shown. You need to combine them in some kind of way. Like in French, you have the CD that's underneath certain letters. That's very similar here, but it's context-based. It's based on the glyphs coming before it, coming after it. Sometimes there's whole swashes attached to words, and our limitation just couldn't handle that for iText 5. So for iText 7, we implemented a new system to handle that, which also loops back to a bit more Western scripts like Arabic, which, if you look at Arabic, it's all one fluent, or at least multiple fluent lines instead of just character by character. So just to highlight, and of course it's important for the talk as well. So this is one of the things that we had to do for iText 7, and we were quite successful at it. So feel free to check that out. But more importantly, we decided not to have an Android port. We didn't see the initial use case in 2017 to 2016 when we released iText 7, because the world was different. Back in 2012, 2011, when we released iText G, the world didn't have as many mobile connections as it does today, as it did 5 years ago. I imagine most of you in the room already had, I think it was 3G back then, 2017, or 4G maybe. You already had connections set up, so having a library that created PDF files on your phone, to us, didn't seem like the best use case out there. We would imagine customers, users just making a call to a server, the server would create a PDF file, and you could download the file or just have a reference to it. So that was our reasoning back then. So we didn't go for it. Well, yeah, spoilers, we did. Otherwise, we wouldn't be here. But back then, we thought it wasn't important. So why now? Why are we now talking about Android? Why are we now suddenly interested in it? And I think this quote by Mike Tyson is fitting, albeit a bit aggressive, I do admit. But everyone has a plan until they get punched in the mouth. So we had a plan. So iText had no Android port because of reasons. We had an intuition of the market. And we stood by what we thought the market wanted. And then you have the punch. And the punch were the download numbers of iText G, which were still going up, and not swindling going up, they were still rising actually. And in addition, the number of licenses that we were selling was still going very strong for iText G. And as many of you probably already noticed like if you have a legacy code base like iText 5 was our legacy code base, it still is, you would like your customers to move on to the next code base instead of trying to maintain the older one. So we would like the number of licenses for iText G, iText 5 for Android to go down, while the iText 7 for Android would go up. In addition, we also were not really selling support for it for iText 5 on Android, where we are sort of selling it right now as well. So that was a punch that threw our plan off. So we reshifted. The unnamed product manager, Andre, came to my desk and he said, like, okay, let's get it on Android. And me being in charge of innovation and research, we looked into it. So the first thing that we do is just we compiled and we ran some tests on emulators, etc. There's a few things that we noticed immediately. So there's a few Android issues with iText 7. First of all, they're a bit of a different category. And that is because we relied less on AWT. We had a few changes in our build system and in the way that we deal with our Java and our .NET builds that have us rely less on AWT. For instance, the PDF graphics 2D class is it's gone basically. For the support people, for the maintainers of that code, that's a good thing. For the users of Swing who want to just render stuff immediately to a PDF file, that's a bit less but of a good thing. But yeah, you can't win everything. We already knew about Bouncy Castle versus SpongyCastle, but Android now shipped with their own version of Bouncy Castle in their own namespace. So they did what SpongyCastle was basically. So now you don't have to rely on SpongyCastle anymore. You can just ship with your own Bouncy Castle version. So that issue was completely gone. We didn't need to look into that anymore, even though we already had the solution. So there's a few more things that we noticed. So first of all, iText 7 is impossible on early Android API levels. For those of you who don't know, so Android works with API levels and certain versions are tied to certain API levels. I'll go a bit more deeply into why it was impossible, and it's very initially a very silly reason actually. Testing is way more thorough. We have a dedicated QA team now. We have multiple QA engineers, test automation engineers working on making sure that iText is tested properly and as good as we can. That complicates things as well in a different kind of way. And plugins, I mentioned that we now have a plugin system where you can just have multiple things working on top of iText. And one of the plugins that we looked at, which seemed to be the most interesting one for Android, is PDF OCR, where you take a scanned PDF or an image and you run it through an OCR system. Ours, OCR stands for optical character recognition, which is a process that tries to recognize text in images. So if you have, for instance, a receipt that you take a photo of for your expense notes, you would instead of trying to transcribe whatever is on the printed receipt, the OCR process would try to recognize everything for you as intelligently or as naively as your engine allows. So that was a bit harder to support for a few reasons. So what's wrong with early API levels, right? So I talked about the iText 7 font refactoring that we did, which was essential to support exotic to us, Westerners, scripts, like all the Indian scripts or the Vietnamese, Thai. Those scripts are a bit exotic to us, right? In order to do that, if you want to support that, you want to use Unicode, which is the standard for fonts and characters. And we introduced a dependency on character.unicode script, a seemingly innocent enum class in Java in the JDK, but apparently that was not available on Android. So If you try to build with API level 20, it didn't work. If you try to build with API level 23, it didn't work. But suddenly they saw the light and they added the small enum class Unicode script, which allows us to detect whether or not a certain character belongs to a certain family group, right? So it would tell us in this case, let me just grab the slide again. I should have added that. So the Unicode script enum would be for us to indicate that this is Devanagari instead of just code points, which would then tell us, okay, now use this glyph positioning and use these ligatures for that function. It's quite essential for what we were trying to do in our font implementation, to be honest. So then I would like to introduce you a bit to our build automation. How does iText build? Because that's quite, or at least how did we automate it? Because there's some complexity to it that adds complexity to how you should handle Android. So on iText 5, we had Jenkins. It's an automated build server, but it's scriptable. If you don't know it, look it up. It's an awesome tool. And our QA team, our colleagues, Marco and his team, they have an awesome set of pipelines to get us through our daily work, to get everything tested, everything built, everything merged. It's seemingly perfect for at least from my point of view. I'm sure Marco will be able to tell you a different story. So in that Jenkins build pipeline for iText 5, we had a script, a very simple script. It's a Groovy script. And it runs through all the code, all the source code on iText. It cuts out any parts that are marked as JVM only or as Android, or exclude from Android or something like that. And we changed the dependencies to SpongyCastle, etc., etc. We did some license key provisions that we also had to change in that code. So we reformatted our code. We introduced markers, and we would position, for instance, all the AWT methods in any given class at the bottom, excuse me, so that we would easily be able to truncate the file. So this is an example of the markers. So you have, it's basically this AWT related methods. Remove this if you're porting to Android or Google App Engine. And then just to highlight why, so here we're using AWT color twice, and AWT image would be a returned object from that. So on Android, on Google App Engine, that is disallowed. So we opted to just delete those because they were not critical to our users, instead of trying to work around them. I know you had, at the time, you had some dependencies, some libraries that you could use, like Apache had Harmony, which offered portable solutions to this. We opted not to go for that, but to just remove the AWT stuff from our Android build. On iText 7, it's a bit more complex. I'll be honest. We have, I mentioned earlier, we have a Java build, we have a .NET build, a C# build, and we keep them functionally equivalent. Which means that whatever you can do in Java, you can do in .NET with a small asterisk, because there's certain crypto stuff that is handled differently, etc., etc. And the way that we do that is that we have a process in place, a pipeline. It's called the autoport, and it takes the Java source code and it translates that to C# source code. Automatically, it works about 95%. For 95% of our classes, it works perfectly great, I would say. There is some, you have to do some manual stuff for the system-related things, or if you are working with signatures, crypto stuff is completely a different system. You don't have the Java cryptography or security interface that Java provides. You don't have that on .NET, for instance. So although Jenkins separates that nicely, this conversion makes the changes that we can do limited. Just as we are writing Java code, we do need to take into account certain constructs that we can and cannot use to make that porting a bit easier. That is a bit of a trade-off that we made, but the gain that we got out of that is immense, because back when we did all those things manually, we had to assign somebody to, and that was quite painful actually, to, after we released for Java, we released 5.5.5, for instance, we had to do a month worth of work just to port all the changes to .NET. So having that automated saves us 1 month in person hours. And a tiny detail, I already mentioned that we have more tests, and we also wanted to run them on emulators because of the way that we do our testing, which will pop up later in the slide deck. So scripting v2. So why would we change a winning team there? So we have a similar concept to iText 5, but a bit more refined. We had more time. We learned a bit, and we introduced more types of markers like skip this line if you're on Android, or just put this one here. We want to use string utils, etc. We have even more complex markers that say, okay, in this method, replace this with replace this with that. So xsize, cut out whatever is in between the start and the end markers, and put in the string utils .join method. So it's pretty convenient, right? The issues that we encountered were not of a big category here. The things that make it a bit more harder, at least that my team spent the biggest time on, was researching how to do the tests. So testing the builds, first of all, you want to build it, and then you want to run it somewhere. And we had a few options. We had pre-made emulators. You could on Amazon, you can go to the marketplace and get the images. So there's I think it's Genymotion that we looked at. So that's a pre-made emulator that you can just run, deploy your APK to it, and then send some commands to it. You also have bare metal machines in which you then have to do everything yourself. There's different issues that goes with each of them, and the one that stuck the most with us with pre-made emulators is that we don't need that they didn't offer hardware acceleration with the pre-made emulators, and let me get that out of the way. And there was no out-of-the-box solutions for the bare metal machines. So that was a bit of a sticky, difficult situation. But we went with the bare metal machines because they offered us more flexibility with our tests and with the issue of how we run our tests. So we're a PDF company, so how we test is a bit differently than how other software companies would test. But we have unit tests, we have integration tests, but we also have what we call compare tests, in which we have a scenario, we have a feature that we want to test in PDF, we run the scenario, and we capture the output. It gets sent to a stream, to a file, to a byte array, whatever the test was set up to do. And then we compare that PDF file against a pre-made reference file. And you can do that in multiple ways. You can do it visually or structurally. Those two are different because sometimes you only care about the visual stuff, and sometimes you only care about structural or the specific PDF constructs. Visually makes sense because a PDF file, if this were a PDF file, you could make, if the slide was a PDF file, you could make it in unlimited kinds of structures. I could, in 5 minutes, I could make 10 PDF files that look differently structurally but achieve the same visual result. So PDF is a complex format. But it's also a very strong and very robust format. But that makes it a bit harder to test as well. So we do have reference files and compare files. So that makes it a bit hard, right? Because you don't want to do that on an emulator. You don't want to compare visually on an emulator. So how the visual tests work is that we use GhostScript in our case on the command line to convert the PDF files to images and then compare them against each other. So you don't want to do that on an emulator. First of all, the emulators aren't as fast as normal machines, normal hardware, and they are a bit limited in their capabilities. So what we did is we mounted a storage as a virtual SD card. Makes sense, right? You write the test outputs to the SD card, and you don't do the comparison on the machine. You extract the PDF files, and then you do comparison off the machine, on a different machine, on your normal build agents. And this is more performant because you can now utilize all your normal AWS agents that you have in your build. If you were looking at building the build, that's a simple Jenkins job that we have. So it's create APK. I mean, why be creative about it? The tests are run in the emulator, and then the artifact is pushed to Artifactory. So if you now go to our Artifactory, which is repo.itextpdf.com, you can find the Android build there. So, and in addition, what we also did was we also offered some source code, some samples. You can find them on GitHub. But we also have a small PDF viewer that you can insert into your Android application. As you can see, we opted for Kotlin here because it's more fun to code in Kotlin. So as I'm drawing to the last few slides, I wanted to preempt some questions from the audience, like why didn't you try solution X? Why didn't you try solution Y? And the first immediate solution that the Android developers in the room will think of is that why didn't you convert iText to Kotlin, right? It's the language to use on Android. It's multi-platform, which means that if you write Kotlin, it can compile to JVM, to native, to JavaScript and Android targets. And in our case, that would mean that we have 3 additional targets, which is awesome, right? Well, we tried. I wrote a prototype called itext.kt. The KT stands for Kotlin, obviously. And it works great. I mean, writing a PDF library isn't some arcane magic. But it was a very minimal one, just a single page document, so it worked perfectly, wrote the PDF files, as you would expect. But even though I love Kotlin and I started using it for my own projects in the last few years, the sad thing is that they didn't have a .NET target. I scoured the internet for it, so if I'm wrong, please correct me and I'll run back to my office. But there was no .NET compilation target. I did find a note somewhere on the bug tracker of JetBrains that they were interested in it, but the compilation or the compiler team didn't have enough people to do it. So as half of our business is .NET business, we couldn't ignore the .NET target, and we bounced back and forth some ideas like. Well, you can just convert from Kotlin to Java and then to .NET, but that's just introducing another step. That's more steps is more fragility. Or you could just rework the auto port to work with Kotlin instead of Java, which meant that we also had a huge amount of work ahead of us for the auto port and for converting iText to Kotlin, which was not something that we intended to put resources on. So unfortunately, Kotlin is not an option for us right now. It is on my watch list, so I have bookmarked all the bug trackers that I could find, all the issues that I could find that were interesting to us. Why didn't you use Xamarin to support Android? So Xamarin is a tool that allows cross-platform apps and libraries. So it adds a layer of abstraction. Instead of using iText directly on the system, you would be using it through Xamarin. And if we would officially sell that, then we would need to support that. And there's a support engineer in the room from my company, and I don't think he would be too happy to have that added as well. So, but most importantly, Xamarin was announced end of life earlier that year, so we got lucky there, or unlucky, depending on how you want to view it. Xamarin does live on, but it does take on a different shape, which we didn't look into at the time. And lastly, why didn't you try JavaScript? And to those people I say, get out, please, and we'll talk never again. So to round off, first of all, decisions are never set in stone. I think this is the second time for a different talk that I say this. The first time is that we had to open source some closed source applications. So as a company, as a group of developers, it's always important to come back or to evaluate your product decisions. And here it's the same thing. We decided that iText 7 on Android wouldn't fit use case-wise, but the market, they punched us in the face, basically. So try to fit the new build system that you have in your current build system. Try not to introduce too many steps, which would have been the Kotlin thing for autoport. And keep performance in mind. iText is relatively a performant build process. So if we would introduce the emulator step, that would increase the amount of time it takes and processing power. Okay, and with that, that was my last slide. If there's any questions, I'm happy to take them now or after the talk on the floor. We have a booth, I think it's number 13, but I could be mistaken. But we're more than happy to talk to you now and later. Thank you.